So let's upload our audio file, which is about what is RAG. And then when it's transcribed successfully, we can ask questions about it, and we expect that LLM is able to answer based on the content of the audio files. So perfect, our file is uploaded, transcribed, and indexed successfully, and you can see that now we have our chat input. I'm gonna just ask what is RAG, and let's see what would be the answer. So the answer is ready. It says that RAG stands for Retrieval-Augmented Generation. It enhances generative AI models by incorporating relative information. Yeah, perfect. The answer is completely correct and based on what we had in our audio file. Hey everyone, Nariman here. Welcome to my channel. Today we want to create a voice RAG. This will unlock the ability to ask different questions about the content of your audio files from LLMs. To do this, we need to first to convert our audio into text and then bring this text to the vector space. And then whenever a user wants to ask a question, we will bring that question into vector space as well. And we will retrieve all the similar text chunks to the user's question, and we will feed them to the LLM with the user's question. So these text chunks that are possibly answering users' questions are our context. We are providing the LLM with this context so it can answer the user's questions about those audio files. So as you can see, the RAG part is not that complicated. It's more or less the same of the RAGs that you implement for chatting with your PDF files. The challenge here is to be able to convert audio files into text with more or less good accuracy. Hopefully, we have OpenAI's Whisper to help us. So recently, OpenAI released Whisper, which contains lots of local models that you can run locally on your machine to convert audio to text. So there is no API call, you don't have to pay for anything, it's just completely local. So if you have a look here, our main dependency to be able to create a voice RAG is OpenAI Whisper. So we're gonna install that. And then I'm gonna use also Streamlit to create a simple UI for our application. And then lots of LangChain related dependencies. I'm gonna use Deepseek as our LLM model. It's available through Ollama, so I need to interact with Ollama. And LangChain offers me lots of great tools to interact with Ollama, create vector store, and many other things. So to set up our project, we need to install all these dependencies. We can go to the command line, and I'm gonna say pip install -r, then voice RAG, and then requirements.txt. Notice that I'm already in the current directory of my project. I'm gonna hit enter, and it will install all these dependencies for you. And then, as I mentioned, I'm gonna use Deepseek R1 as our LLM. So make sure that you have Ollama installed, and then you already pulled Deepseek model. You need to call Ollama pull Deepseek -r1, then a colon, and then there are many different parameters. I'm gonna use 8B. The bigger the model, the accuracy is better, but of course you need more machine power. So if you have a strong laptop, go for better models, but I'm gonna stick with 8B, which is more or less a good option. It runs fast enough on my laptop. So after this one is pulled, you are good to go. We can go to the code again. I already created a simple structure for our project. As you can see, First of all, user will upload an audio file. We're gonna upload it and store it somewhere in this audio directory. Then the most important part, we are gonna use Whisper to transcribe the audio. Then we are gonna split that text into smaller chunks because LLMs work better with smaller chunks of text. We are gonna bring those text chunks to the vector space and then store them in a vector store. This will be done in index docs. And then we are basically done. We set up our RAG. Then user will come and ask a question. We are gonna pass that question to our vector store, retrieve all the related documents. This will be done here. And then with the provided context and the user question, we are gonna ask the LLM, okay, answer this user's questions. And as you can see up there, I already have a template for our prompt that is saying you are an assistant for question answering. You need to use the following pieces of retrieved context to answer the user question. And then we are gonna provide the question and the context, and we will expect an answer from our LLM. As I mentioned, I'm gonna use Ollama's Deepseek R1, both as my embeddings and also as my model. And I'm gonna just use an in-memory vector store. You can use something with persistence like ChromaDB. For this showcase, I'm just gonna stick with a simple in-memory vector store. So that's it. That's our high-level view of the project. Now let's get into the detail and write some code. Upload audio is very simple. You have a file and you want to store it in a local directory, which we have here. So it's just pure Python working with files. I'm gonna do with open. Then I have my audios directory. And then I'm gonna open it as write mode, and then I'm gonna write it to the file. Very easy, very straightforward. And then here, the transcribe audio, we need to use Whisper. So Whisper has many models. You need to decide what you want to load. I'm gonna use something not so big, not so small, so we can get an average accuracy, but it's not gonna take so much time to transcribe it. So there is a medium model, and then I'm gonna use only the English one, because here I'm assuming my audios are all in English, so I'm gonna use the English specific one. You can visit their documentations and you can see that there are many models with also different languages. I'm gonna stick to this one, and this will be Whisper model, something like that. Yeah, let's call it that. And the rest is also very straightforward. You're gonna just call your model, call transcribe, and then say, okay, file is there, give the file path, and then let's store it in a result. And then it has a text field that we are interested in. So if you return the result with the text key, yeah, like this, it will give you the generated text from that audio. Also notice that for the first time that you are loading the model, it will download it. So the first time that you are running your code, expect that it takes some time to download the model. Then we need to split the text into smaller chunks. I'm gonna use the recursive splitter from LangChain, yeah, this one. Something like a chunk size of like 1000 should be good enough. Yeah, like this. And I'm gonna call this text splitter. And then just call the split text on this, and it will give you a list of text. So that's it. Index docs contains of using the embeddings on the chunk of text bringing it to vector space, and then store it in the vector store, which all of this operation that I explained to you can be achieved by calling vector store add text and passing this text to it. So in code, it's just very straightforward. Same as retrieve docs. Again, you bring the query into the vector space, then hit the vector store and check the similarity of the query vector with all the document vectors, and then retrieve the similar ones. But in code, it's just a simple similarity search function call. It's like vector store similarity search query. So this similarity search will do all the operations that I told you. And when user asks the question, we are going to answer it using all the retrieved documents. So we need to create a big chunk of text by appending all these document contents together and pass it to LLM. So we can use basically Python's join to append this all together. So let's do that, like maybe 2 new lines and then join. And then if you have a look here, you can see that similarity search will give you a list of documents. This document is a LangChain defined class. So when we want to get the page content from this documents, we need to do something like this. Go over all of these documents and then get the page content field. This has all the text. The other fields are like metadata. So that's we are most interested in. We can go ahead and call this context. And then we need to create a prompt out of that template that I showed you here. There, we have a template. We need to create a chat prompt template from that. And then we need to create a chain out of the prompt and the model. So like this with pipe, we are gonna connect these two into a chain. And we need to just invoke this chain with these two parameters, question and context. Notice that here we have question and context. So let's go ahead and do that. And the answer would be the answer that we need. So we are just gonna return it, chain.invoke. So it's gonna be a map, and then question would be this field, and the context would be the context that we created out of these documents. One more thing that is left is that these reasoning models usually give you their thought process, and I don't want to show that to the user. So for Deepseek, it's usually inside the think tag. So I'm gonna use regular expressions to remove that. So you will go and say, I want to replace a pattern, which is think, looks like XML tags or HTML tags. And this is the closed one. And anything in between, which I will show like this, I want it to be replaced with nothing. So I want to just remove this whole text inside the think tag. I'm gonna pass the text that I want to clean, and I'm gonna also add a flag re.all, which controls how we are gonna treat new lines as well. And this will be my, let's call it, I don't know, clean text or cleaned text. And then let's also call a strip on it, which removes white spaces from the beginning and the end of the text. And this is what I call a clean text. And then I want to call it on the response of the LLM. So this way, the response would be completely clean and without the think tag, and I can just call answer question right away and show it in the UI. So now that we are done with the logic of the voice RAG, we can go ahead and create a very simple UI. I already created a file uploader using a Streamlit, which says, okay, upload audio. I'm not allowing multiple file uploads. And let's say for now, we just accept MP3 formats, which is a very common format for audio files. I'm gonna say if there is an uploaded file, go ahead and upload it and then transcribe it. And as you know, it's in the audio directory that we created. So I'm gonna give it an exact path to that file. And this is gonna be my text. Then I'm gonna split that text into smaller chunks. I'm gonna call this chunked text, like this. And one more step left for us to index these texts. So let's do that. And then using a Streamlit, we are creating a chat box for user to ask some questions. And when we receive the question from the user, I'm gonna say, if there is a question, first retrieve the docs that are related to user question. This I'm gonna say related docs. And then I'm gonna ask our LLM to answer this question. So it's gonna be question with these related docs. So this will be our answer. And now we need to also show these in UI. So when user asks the question, I'm gonna say st chat message. And the question belongs to the user. So the role is the user. Let's write this question. But when we have the answer, we are gonna say st.chat message, but the role is different. It's now the assistant who's talking. So we're gonna show it as the assistant message. So yeah, that's it. Let's go to the command line now and try to run our project. I'm gonna say Streamlit run, and then we're gonna find our Python file. Let's hit enter, and then we can go to our browser, and you can see that we have a very simple UI here. So for the audio file, I decided to use an AI generated audio. There is this OpenAI.fm, which right now is a demo of how cool their text-to-speech is. So you can use many different voices. You can even select different vibes. And then I used a piece of text from some article on what is RAG. I think the article was from NVIDIA blog. And I'm gonna ask AI to read this and give me an audio file to use in our application. So I can click play here.
Retrieval-Augmented Generation, aka RAG, is a technique for enhancing the accuracy and reliability of...
I don't know how well you can hear it through my microphone, but it's reading it pretty good and it's very accurate. So I already downloaded it before. So let's go back to our voice RAG example. So let's upload our audio file, which is about what is RAG. And then when it's transcribed successfully, we can ask questions about it, and we expect that LLM is able to answer based on the content of the audio files. So perfect, our file is uploaded, transcribed, and indexed successfully, and you can see that now we have our chat input. I'm gonna just ask what is RAG, and let's see what would be the answer. So the answer is ready. It's saying that RAG stands for Retrieval-Augmented Generation. It enhances generative AI models by incorporating relative information. Yeah, perfect. The answer is completely correct, and based on what we had in our audio file, you can use it with many different audio files. For example, you can give it podcasts and then ask questions about the content of that podcast, or I don't know, the audio that you recorded from your professor at the university in the class. I tried Whisper a couple of times on my local machine, and I would say even this medium model is pretty solid, at least for English. I didn't try any other languages, but at least for English, this voice RAG can give you really good results. So yeah, that was it. I hope you enjoyed watching this video. Please like it and also subscribe me for more content like this. See you around.